My name is Terrence Render, and my presentation is in regards to the SQL injection attack detection using fingerprints and pattern matching techniques. The purpose of this research topic is to examine how pattern matching, Corsic and Moore's algorithm, for example, and fingerprinting techniques, Rabin technique for fingerprinting, can work cohesively for more efficient SQL injection attack detection. This is also going to explore how detection can improve on false negative and false positive results when working to determine the presence of SQL injection attacks and its accuracy. With SQL injection attacks, we're going to look at the background, the problem solved, the methodology, the simulation of the results, and so forth, um, in regards to the experiments and the variables presented in this research document. Let us begin with understanding SQL injection attacks. First, we're going to look at what exactly SQL is. So just a quick definition. SQL queries can be defined as a string comprising of tokens. What are tokens? Well, tokens are a combination of things such as um, identifiers, operators, keywords, various symbols, literal values, and so forth. Um, when it comes to SQL injection attacks, cyber criminals utilize injection by sending invalid data to a web based application, for example. This is to produce an outcome the affected application is not meant to do. It wasn't programmed for the outcome that does occur. Now, to further explore SQL injection attacks, um, injection attacks are among the top 10 security risks, according to the OWASP. There are multiple variations of SQL injection attacks. While SQL injection attacks are seen as simple, this technique, when utilized, has severe ramifications and can cause severe damage to a web application's database. It is not to be taken lightly. With SQL injection attacks, as I mentioned, they have different variations. Now, to begin, the first variation we will look at is the first order injection. SQL statements injected via cookies, HTTP GET or POST input, as well as other server variables, environmental parameters, as well as network headers. There's also the second order injection. Second order injection is when a SQL statement, they are injected into a trusted source, a quote unquote persistent storage, which is then utilized to commence an attack indirectly due to the malicious input being used later. Following the second order injection, we shall look at the illegal, logically incorrect queries. Now, this variation of an attack is actually part of the preliminary stage for setting attacks. Um, it gathers intel prior to subsequent SQL injection attacks. A legal or logically incorrect, if you will, SQL syntax is injected in order to reveal injectable parameters and other vulnerabilities. This allows the hackers and bad actors and so forth to access info on the back end database of an application. Now, with tautologies, a query that is injected for the purpose of identifying injectable parameters, extracting data and or bypassing authentication barriers. This is done via the query always evaluating as true. Next, we are going to look at union query. Union select is injected for the purpose of deceiving an application to return data from an unintended table. Following union query is piggybacked queries. These queries are sent after the first normal query for the purpose of carrying out the attacks. These additional queries piggyback on the primary query in order to modify, add, extract data, and so forth, carry out remote commands, or even denial of service attacks. We now reach stored procedures. It is a SQL statement that is stored as a procedure that can later be replaced by another stored procedure in order to execute remote commands, such as privilege escalation, as well as implementing denial of service. Now that we have explored the variations, if you will, of SQL injection attacks, we are now going to look at SQL detection. Once we explore SQL detection, we're going to then look at the experiments that occurred during the research portion, which will answer the questions posed at the beginning of this presentation. Let us continue by exploring SQL injection attack detection. Um, we'll first start with a brief review. Since SQL query is a string comprising of tokens, um, the formation of these tokens arrangements can in fact illuminate where there may be malicious SQL. The goal of SQL injection attack detection is to differentiate between legitimate and illegitimate injected queries. This can be done via extensive analysis of tokens, which are then compared to existing text signatures prior to forwarding the SQL query to the server of a database. Fingerprinting and pattern matching are utilized in order to identify malicious SQL injection. This can be divided into the following processes: programming and query. Programming is where the query is analyzed to ensure there is no trace of quote unquote exploits from an individual's input. The query, phase two, if you will, further examines, acting as a second layer of analysis, if an initial match isn't discovered in the prior examination. Here, we have a SQL injection attack detection framework visual representation of what we will further explore in the next few slides. Let us further explore the framework design rationale. The fingerprinting method is utilized as the first step. This allows the pattern matching method to avoid the high computation efforts associated with its examination. Ray-Ban fingerprints represent both the attack and query signatures. The input text is converted into tokens regardless of it being an attack or query signature. Programming. Programming is only performed once. The only time an update will occur is when a change occurs in the signature database. The attack's signatures are fingerprinted and represented with short digests. They are then stored in a table. Each string is represented as a binary representation of integers. This can be seen below in the two images. Query. Query fingerprints are computed digests matched against digests of attack signatures generated during the programming phase. Computation complexity is reduced via allowing left shift operations to replace the multiplication in Ray-Ban fingerprinting. Negative results, as you can see, they are considered legitimate due to not matching attack signature fingerprints. Further pattern matching would not be required in this instance. However, should there be a positive result, the Karasik algorithm is utilized to determine whether the token matches an attack signature pattern from the prior match. The Aho-Karasik algorithm will be utilized in the event only if you will receive a positive result. Next, we will examine the experiment's process as well as findings in the subsequent slides. In order to prepare, SQL injection attacks were launched, utilizing various tools multiple times with every setting possible to ensure a wide range of SQL injection attacks would be captured and analyzed for this experiment. Here are the findings. There were 1,134 queries. This included both genuine and injected. Um, the data set post duplicate removal results go as follows. Injected 527 tokens, genuine 343 tokens. Just to point out, we do have the system specs for the machine used for this experiment as well. Here is a visual representation of some of the findings from the SQL injection attack detection experiment. We have listed the max first order injection at 86 and the minimum captured totalities at 57. You can see that at row 3 of table 3. Regarding the experiment's results, the system's performance is calculated based on table 1's values. False matches are greatly reduced, as shown in table 2. Highly accurate high detection rate with low false positive and low false negative results were present. Multiple SQL injection attack methods were detected at various rates. This is shown in table 3. The highest detection rate was the union query, meaning all were detected. at 100%, and the low detection rate were among the piggyback and stored procedures. Utilizing the Raven fingerprint prior to pattern matching resulted in a highly efficient detection. This is due to its quote unquote sanitizing technique as opposed to false matches from the pattern matching due to factors such as various attack types and short length patterns. Impact on performance. Processing time. Higher processing times means there is a malicious string. The queries are longer than queries that are genuine. Lower processing time means there is a genuine string. The fingerprint table's size severely affects the performance of the Raven fingerprint method. During the experiment, there was an observation of a delay with each load of the page when executing many queries. However, the user experience was not significantly affected. There is a relationship between memory consumption and processing rate in this framework. Detection can improve with reduced fingerprint collisions via a larger signature database. A reduction in a signature database size will negatively impact efficiently but reduce memory consumption and processing time. Now, we are at the conclusion of the research presentation. In conclusion, utilizing a combination of fingerprinting and pattern matching does equate to a more efficient manner of detection. Employing Raven fingerprinting prior to the pattern matching algorithms yields a more streamlined approach due to its more accurate results. Furthermore, to continue the research of attack detection, there must be a method to identify unknown attack signatures. The goal is to use an anomaly-based system that will be able to identify the normal database access executed by web applications. This will be done via learning the database's usual access profiles in conjunction with utilization of different models and a signature-based approach to detect unknown attacks.